think we are live now. Yes, we are. I just need to open this up again. 1 second, guys. Okay, yeah, we are live. So I'm just going to close this. Um, we'll begin in 1 minute. Give me 1 minute. I'm just setting one thing up. I should be looking there. We'll be beginning in 1 minute. Just 1 minute. Yes. Okay, cool. Perfect. My screen is visible to everyone. You guys can see the hatch window, and you guys can see this hatch window as well. Okay, so let's begin. I hope I have fixed my mic, so my audio should be clear as well. Just give a thumbs up or message something. Send a W, W for win. Send a W if my audio is clear. Everyone, uh, cool. So you guys know why we are here today. We are here to learn how to create a good Space Invader game. The classic Space Invader game that we used to have on our old Nokia phones, the 2D Space Invader game, or the classic Atari Space Invader game, right? So we are here today to learn about how can we code our very own Space Invader game on Hatch in 3D. Now, what I have for you is, let me first of all show you how our game is going to look like. Okay. So good, good, good. I get that my audio is clear, so you guys can stop spamming. Okay. So I'm just playing the game here so that you can see what we will be coding. So you can see I have a shooter in my on my project, and then there are some enemies that are moving left and right. Yeah. And now how this game works is if I press my left arrow key, my shooter moves to the left, and if I press my right arrow key, my shooter moves to the right. Then, as I press my space key, you'll see I'm firing bullets. And you will notice that as I'm firing bullets, as those bullets are hitting the enemies, those enemies are getting killed, right? So remember what are the things happening in this game, so that when we start coding, we will code all of these things one by one. All right. So before we start coding, before we start doing anything, uh, I mean this is going to be I am trying to make this an interactive session. So see, there is an option. So sorry. So you can see this game I have coded on Hatch using JavaScript. Okay, you can see the entire code. I'll show you guys how to code this. Otherwise, you can notice I have coded the same game on Hatch Kids. So now you guys can decide, what do you want to learn today? Do you guys want to do JavaScript coding and make the Space Invader game on the Hatch Adults platform? Or do you guys want to learn how to make the Space Invader game on the Hatch Kids platform? Just message in the chat and I will be able to see what do you guys prefer. Okay, see, the game is the same, but just that on Kids you'll be learning how to code this using blocks, and on the JavaScript, on the adults version, you'll be learning how to code this using text-based JavaScript. Uh, Text-based JavaScript might be difficult for some of our younger audiences to understand, so I'm going to take your opinion into account, and then we are going to code that way. So, okay, some of us, I'm getting a lot of. So I have had two responses of Hatch Kids, one response of Hatch XR. Guys, you say. Otherwise, I'll choose on my own in the next one message per person. I can see you. I can distinguish this. Okay, just one message per person. Don't spam, guys. Okay. At least the people who are responding are saying hatch kids. So I was hoping for hatch adults, but sure, why not? Let's do hatch kids. Hmm. Actually, uh, let's do Hatch Adults this time, and I will share the both of these project links, and all of these are going to be available on the Discord channel as well, so you guys can look up references there as well. So you will be able to access the block-based project on the Kids Gallery as well, and I'll share this on the Discord channel as well. But I am more leaning towards this JavaScript version today. So we are going to do JavaScript version today. Uh, okay, good. So let's get started. I'm just going to close both of these and I'm going to open up Hatch. And yeah, guys, just stop spamming now. Got your read your messages. Don't make the chat non-interactive for other users. Okay, so we are going to start our game. As you can see, I'm on the Hatch website, and you guys can. Oh, my video is freezing. Okay, I'm going to open up a new project. I'm going to open up a new project. Good. So, how are we going to start the project? Remember the stuff I showed you? First of all, we are going to add a shooter, and then we are going to make it shoot bullets. Then we are going to make our shooter move left and right? And then we are going to add enemies, and then the enemies are going to move left and right as well. And then we are going to write the logic of the bullets hitting the enemies and killing the enemies. Okay, the game is we are going to code this game in smaller steps, and you how the whole thing works. So this is the Hatch adults page. You can see there is an empty project here. I'm just going to start by adding a spaceship, okay, because we are going to add a shooter and make it move left and right. That's the very first thing we're going to do. So I'm just going to delete everything here that I see. So I don't need a box sphere cylinder. I just need to add a spaceship. So I'm just going to go to the Google Poly section and spaceship, spaceship, and yes, good. So I can see it gives me a lot of good options for spaceship. I can add, let me just add this one. This is a good one. So yeah, my spaceship is added. My spaceship is added, and now yeah, it's very far away. I'm just going to place it near the player's position. So I'm just going to position it at 000. Now 000, you'll notice the spaceship is facing the opposite direction from the camera. I'm just going to flip it 80 degrees. Okay, so yeah, now you'll notice the camera is just above the spaceship. We don't want that as well, because right now if I go to the play window, is that I can't see the spaceship directly. I'll have to tilt my camera a lot to see the spaceship. That's not good. So let's just move the camera a bit up so that it has a good viewing angle for the game. So I'm just going to move, I'm moving the camera behind. Okay, yeah, I can see the number here. I'm just making it 5 in the Z direction, and I'll make it slightly up as well, so 2 in the Y direction. And then let's see how it looks like. So go to the play window, I can see what my camera is going to see while I'm playing the game. So you guys can see that cool. I'm just see. I'm going to go a bit faster here. So if you guys find a few things that you fail to understand, then just rewind the video and watch that section again. So here I can see I can see the spaceship in front of me, but I think I'll need to tilt my camera. So I need to tilt the camera to see the entire spaceship. So I'll go to the design tab, player. I select the player. I select the rotate option, and I tilt it slightly. Yeah, I can see the rotation value. I'll just make it -10. Okay, so -10. Yeah, now let's see if this looks okay. Yeah, this seems to be a good vantage point for my camera. You'll also notice that right now, if I press my left or right arrow key, it appears as if the spaceship is moving. But what's happening is the spaceship is not moving. My camera is moving left or right when I'm pressing the left or right arrow keys. We don't want that. We want the player to stay where it is, and we want the spaceship to move left and right. So to do that, we have to follow player's position. So for that, we'll have to select the none option in my player motion property. So I select that. And now if I go to the play tab, you'll notice that if I press my left or right arrow keys, nothing is happening. Good. So we have our position. So now when we press our left or right arrow keys, we only want the spaceship to move. Okay. It's a bit dark. I'm just going to add some amount of light as well. Yep, I think that works. And 0.7, good. So I have a light source. Now let's go to the code window and understand how can we code the left and right movement. Now, in your classes, in all of your few previous YouTube sessions, or in your classes, you guys learn about moving using forever loop, or you guys learn about moving using timers. Yeah, that's the most common stuff that you guys do. But we are not going to use those. We are not going to use timers right now. I'll tell you why. We are forever blocks is something that you use in block coding. We are going to thing in JavaScript that is an equivalent of how forever blocks work in block-based coding. Okay, we are going to use a command called request animation frame. I'll tell you what happens, what it does. So what happens is whenever you're looking at your computer screen, your computers, your any electronic device, they have a refresh rate. They have a screen refresh rate. Some screens, mobile phones are nowadays coming at 144 hertz, 180 hertz, 120 hertz, right? TV screens mostly are of nowadays TV screens are of 60 hertz, 120 hertz as well. But yeah, what basically that means is your screen is getting painted on every 120 times every second if your screen's refresh rate is 120 hertz. Like my laptop screen refresh rate is 60 hertz. So it means that it's getting painted 60 times in every second. So we are going to use this we are going to use this knowledge of when my screen is getting repainted, and we are going to code our object's motion with that. So first of all, I'll explain when I start coding that. So first of all, to make the spaceship move, what do we need? I'm just going to use a speed variable. Okay, I'm going to create a variable that is going to give it speed. But my spaceship is going to move where? In the left and the right direction. So it's only going to change its x coordinates, nothing else. So what I'm going to do is I'm just going to create a variable. I'm just calling it x speed. I'm giving it a value 0 for now. Let's start with the value 0, and we can modify the value later on anytime we want. I hope my screen is visible, as in the text that I'm writing here is visible. And let me just zoom up. Yeah, this should be visible now to everyone. Cool. So I'm creating a variable x speed that is going to control the speed of my spaceship. Now I'm going to write the code to move my spaceship. So I'm going to create a function. Okay, uh, giving it a name, move ship. Okay, and I'm going to move ship. Now what is move ship going to do? Move ship is going to move my spaceship, change the x coordinate of my spaceship. So how do I do that? I'm just going to say spaceship dot set x to spaceship dot from its current position get x plus the speed value. So we'll do that. Spaceship dot get x plus x speed. Okay, x speed. Okay, but so now all to make my spaceship move, all we have to do is run this function again and again and again and again. And what we will do is we are going to use this request animation frame function that is going to run the move ship function again and again every time my screen gets painted again. Okay, so the way to use a request animation frame function is create a variable, give it a name. Let's say I'm giving it a name m, and then I write window dot request animation frame, a pair of brackets, and inside the brackets you write the name of the function that you want to start running. So this is you're writing it outside. To indicate the first time your function will start running, I'm just going to give the name moveship here. And now what we'll do is, so see, now what will happen is when my computer starts running the code, it will first create a variable speed equal to 0. And then it will create another variable m. And it reads that it is the m variable is saving a value of a new painted screens of a new paint of the screen uh, that is supposed to run with the move ship function. And what is move ship function doing? That is moving my spaceship, changing the x position of my spaceship. It's only going to do it once. Line number 3, that is changing the position of my spaceship, is only running once. What I'll do is, what to add animation using request animation frame, what you do is inside the function you write the same line of code that you write outside. So I'm going to say m is equal to window dot request animation frame move shift. Now see, when my computer reads line number 3, it goes to the move shift function and performs the activity of move shift. So it performs this activity of changing the x position of my spaceship. And then it goes to line number 7. That tells my computer what? Perform this activity again. And then again it will go to line number 7. And then this line number 7 tells my computer to perform the line number 6 activity again. So this will keep on now happening. This activity, this line of code is going to keep on happening again and again and again and again every time a new screen is painted on your screen. Now screens get painted at a very fast rate, so you don't notice with your naked eye that your screen is getting painted again and again. But your computers know that it's painting every single pixel again and again. So it will be able to, every time it paints a new screen, it will move the spaceship's position slightly to the left or to the right depending on the value of x speed. Okay, good. Okay, now uh, technically this should work, right? This should work. But if I run the script, you will notice that my spaceship is not moving. That's because x speed value is 0. And when x speed's value is 0, the set x to get x plus 0 is not changing the x coordinate of my spaceship. So what are we going to do? We are going to now make our spaceship just change the x speed's value when we press the left or the right arrow key. Like when I press the left arrow key, what do I want? I want the spaceship to move to the left side. So what does that mean? It means that my spaceship's x coordinate is decreasing. So x speed negative value. And when I press my right arrow key, it means I want the spaceship to move to the right side, and that means my spaceship's x coordinate is increasing. And when it's increasing, it means x speed is going to have a positive value. So we're just going to do that. We're just now going to write a simple on key down function. We can find that in the scenes and events on key down. And you just write an if else statement. I mean, this is something that now you guys are familiar with, so I'm just going to show you here. You write an if else statement if event dot, I use key codes value, so that's more comfortable for me. So the JavaScript key code for the left arrow key is 37. So this is indicating that if the left arrow key is pressed, I'm saying x speed's value, change it to 0.05. It's just a random value I'm taking right now. The whole purpose is it has to be a negative value because I want the spaceship to move to the left side. And in the left side, its x coordinate should be decreasing. And similarly for my right arrow key, else if, just say event dot key code double equal to 39. 39 so is the right arrow key's key code, so 39. And what do? We give the x speed a positive value. So I'm just going to give it 0.05. Now, if I run my script, when I press my left arrow key, my spaceship should move left, and when I press my right arrow key, my spaceship should move right. Try it out. It's a very simple code that is not going to freeze up your computer at all. The request animation function is very smooth. It doesn't slow down the system at all. See, and it's very efficient. And how smoothly is my spaceship moving? I'm just pressing my left and right arrow key. Okay. Step of the game done. Now, what's the step two part? We have to add a bullet and then fire the bullet every time I press my space key. Um, Guys, you can just rewind the video. And is my video freezing? 1 second. My video. Oh, my camera is frozen. I'm so sorry. Give me. Give me 1 second. Oops. Uh, I am so sorry. Just my setup seems to have. I'm just going to add a. Where is my display capture window capture? Oops. Display capture. Yes. I'm so sorry. My setup seems to have messed up. I'm just going to video capture device again. Give me a small break, guys. I'll. In the meantime, just rewind the video and. In the meantime, just rewind the video and yeah, just do the same activity I showed you. Okay. Okay. Perfect. And oh, damn it. I need what? I need to. Oops. Um, just one more. I'm really sorry for this. This should have been an easier thing. What the heck am I doing here? Yes, good. Um, am I on focus? I seem to be on focus. My audio was echoing. It won't be echoing anymore. Yeah, good. Wow, I'm really sorry for this hiccup. Okay, I don't know what. Guys, it seems like my camera is malfunctioning. I'm just going to try it one more time. Sorry. In the meantime, try out the just do the movement stuff. I'm just going to try it one more time. Otherwise, we'll continue without my camera. Okay. Okay. Good. Um, focus. Change the size. Alt. Change the size. And I'm just going to select filter. Okay. Close. I hope I don't freeze up. If I freeze up, please ignore. Just message and Let me do something about it. Let me just put myself on focus. Damn it. This took a lot of time. We wasted a lot of time. We are going to catch that up. Okay. This is just a random green screen that I use. All right, cool. So let's continue. Let's continue. I'm so sorry for the delay, for the hiccups. Wow. Oh, damn it. I'm so sorry for the delays. Let's continue. So now, spaceship moves. Spaceship moves left and right. Yeah. What to do? Make the bullet fire now. So to do that, we go to design, and in the design tab, what do you need to do is you need to add an object that we will use as our bullet. So I'm just going to add a sphere. Add a sphere. Now this is a very huge sphere. Let's position it at 0, 0, 0. I'm going to reduce the size of the sphere to, yeah, 0.05 seems okay. And I'm going to make this sphere invisible because we are not going to be firing this sphere object. Every time we want to press our space key, what we will be doing is we are going to create a copy of the sphere and fire that. Okay, this is just going to be our reference bullet. Okay, good. So firing the bullet. So I've added the sphere now. Let's go to the code window and understand how we can write the code to fire it. Before that, it's too blue here. I'm just going to do some few design changes. I'm going to add a gradient sky and make it all black. Let's do that. I'm going to add a star system, and yeah, this seems good enough. Okay, so I have stars, I have a black background, I have my sphere that I'm going to fire as bullets. I go to the code window. Now, what do we need to do? Every time we press the space key, we are going to create a copy of that sphere object that we just saw. And then we are going to fire that. Okay, so let's first start by creating those bullets, as in creating copies of the sphere object every time we press the space key. So what do we need to do here on key down? We are just going to write what will happen when we press the space key. So else if the key code of space key is 32, so I'm just going to use that event key code that is equal to 32. Something is supposed to happen. Uh, Something like creating a bullet. Okay. So the reason I'm writing it this way is I'll create a function with the name create bullet, and in that I will define the functionality of how my computer should create a bullet. Okay. So create bullet. Now we can tell it what should happen here. So what should happen here? We are going to clone our sphere object first of all. So how do we do that? We are going to go to utilities and clone object. Close this thing. Just, yeah. Close this as well. Perfect. So we have the hatch.clone object function. Now here we have to define what object we're going to clone. So I'm going to clone my sphere object. So write sphere. Okay. Sphere hash.clone object sphere, and then the clone object's name is temporarily going to be cloned object. Okay, so here now we can change the position. So now every time we are creating a bullet, we have to create the bullet from the spaceship's position. When you press the space key, at that moment, whatever is your spaceship's position, that is when you're going to create a bullet, right? Every time we clone this object, we create a bullet, we have to set its position to exactly where the spaceship is. So we do that here. So we say, rather than saying to here, you can just say spaceship dot getX. Okay, and then just copy this line of code 3 times for y and z values as well. Okay, so you have get y, set the y position of the cloned object, and then you have set the z position of the cloned object to get z. Okay, one more thing. Remember, my original sphere is not visible. So we have to, this cloned object will also not be visible. We'll have to make this cloned object visible. How do I do that? Just set visible to true. So cloned object dot set visible to true. Okay, good. So this should at least be creating a new bullet every time I press my space key. Let's see if that works. So I'm going to, yes, see? Now every time I'm pressing my space key, my this spaceship, wherever my spaceship is, a new bullet is getting created. Good. So this much is working. Now we have to write the code to make all of our bullets move, right? So that's really easy. What I'm going to do is I'm just going to first of all create a variable, an array variable where I'll store first of all of these. How many bullets do I have in my scene, right? So before this, I'm just going to create a variable called bullets and just tell it the variable bullets is what is an empty array. It's going to start as an empty array because originally in the scene there are no bullets, and then as you press the space key, we are going to keep adding all of these bullets that we're creating into my array. So how do I do that? There is a very simple JavaScript function dot push. So if you just say bullets dot push, and then so push adds an object at the end of an array. Okay. So bullet dot push means add whatever object's name I write inside the brackets at the end of the bullet array. So I'm just going to give it the name cloned object. Yeah. So cloned object, every time I create a clone object, add this new cloned object as the last element of the bullets array. That's what this is doing. Good. So now this is not going to show visually any purpose here in your code, but logically it needs, so we need to do this because now that all of your bullets are in one array, all you can do is loop throughout the array and change the z position of all the elements in the array. That's how you move the object, move each of those bullets. So for that, I'm just going to create another function called move bullets. Okay, and easy enough. I'm just going to say, first of all, we'll check if there are any elements in my bullet array or not. So if uh, bullets dot length is greater than 0. Okay, dot length for an array checks the length, how many elements are there in the array. So if there are no elements in the array, then there is no bullets to move. So we need to check that because we are starting with an empty array. Now inside this, we are just going to say for. Now loop through each of the elements of the array. So there are multiple ways you can do that using I equal to 0, I less than, bullets length minus 1, I plus plus. The regular way, we can just say let d of bullets. So basically it's just going to loop through all the elements of your bullets array, giving them a temporary variable name of b. So b, so this is a way, this is another way you can loop through an entire array. So b dot, what do we need to move? Change the z position to move the bullets forward, right? Uh, yeah. To move the bullets forward, you have to change the z position. So when you're changing the z position, it's decreasing. As it's moving forward, forward is the negative z direction here. So I'm just going to say b dot set z to b dot get z plus I'm going to create some variable that will control the speed of my bullets, b speed. So I'm just going to create a variable at the very top of my code here. The variable b speed equal to what do we want our bullets value to be? Let me just keep it as minus 0.05 for now. Okay. Yeah, but this is again only going to run once. So we to loop this again and again, we'll have to do the same activity as the window request animation frame that we did for move ship. But now this is where again you get the benefit of this using request animation frame before rather than using a timer. Uh, you would have added multiple timers. I don't want to add multiple timers. Multiple timers slow down my system. I can simply just use a single request animation frame again and again. So what I can do is I'll just create a function called run game, and this is going to I'm going to change this name here of move shift to run game. You'll see what I'm doing here. You'll understand what I'm doing here. I'll explain what I'm doing here. Run game, and rather than running this function again and again, what I'm going to do is I'm going to run this run game function again and again. Okay, run game. Is my I'm just checking if my damn it, guys, my audio was echoing. Was it not? I'm so sorry. Okay, it won't be echoing. It won't be echoing anymore. Okay, so I'm going to run this request animation frame on my run game function. Now, how does it benefit us? Now, inside my run game function, I can define all the functions that I want to be running continuously again and again and again and again. So here I can just call my move shift function, and then I can also call my move bullets function. I have not created, or I have created move bullets function. Okay, so now see this move bullets function and move ship function. Both of them are going to be running again and again with this single request animation frame, and it's going to run very smoothly. So now, if I press my space key, yeah, see, I'm able to fire all the bullets, and the bullets are moving. Okay, I hope I'm not boring all of you guys. There's a very small part left now, so we'll just go through it faster. Okay, bullets are moving, but you'll notice the bullets are still in the game. They will keep on, however many bullets I, they will keep on moving forward, and they will keep on moving forward forever. They are not going to stop moving. So from the very start of your game to the very end of your game, all the bullets that you fire are going to exist in your game. And what happens is that will slow down your system. What we can do is because we are going to add our enemies in a specific region of our space here, right? So we know that if my bullet has not those enemies and it has moved beyond the region of where my enemies are, then there's no use of that bullet. So we can write our own code to destroy those bullets the moment they pass beyond that region. So we can do that in our move bullets function itself. So here, for every time we do this, every time the bullets move forward, we can just check if actually we can just check it out after the for loop as well. We can just check it here as well. If so, another thing, I'll just so see. I'm going to open up a whiteboard. Let me try out on this. So what you have is you have your bullets array. Okay, it has some elements here. Your very first element has the index 0. The very first bullet that you fire has the index 0. Then the second element that you fire has the index 1. Then the third bullet that you fire has the index 2, and so on. Okay. Now see, all of these bullets are going to be behind my bullet 0. Okay. So if the bullet 0 has not crossed our boundary limit, then obviously bullet 1 to the very last bullet have not, right? So that's all we have to do is check if bullet 0 has crossed the boundary or not, a boundary limit that we are going to define, okay? And if bullet 0 has crossed that boundary limit, we can just destroy this bullet 0 and rename all the other bullets again, starting from 0, 1, 2, and so on. All right. So this is how. So we don't have to check for each of the bullets whether all the bullets have crossed the boundary limit or not. Every time my bullets move forward, I just check if the very first bullet, that's the farthest in my scene, has crossed my boundary limit or not. Okay. So what I mean by boundary limit is a specific Z coordinate after which my bullet has no use. So right now, let's just try this out. That Z coordinate of our bullet, if it becomes less than -10, my Z coordinate is decreasing for all of these bullets. So from 0 to -10 to -20, -30. So let's just say if the Z coordinate of the bullet becomes less than -10, then the bullets have no use. So what do? You just see, I can just say bullets and then square brackets to write the index 0. Check the Z position of this bullet 0 element. So check, how do you check it? Get Z, right? And we check if it's less than -10. So if this is less than -10, then what we are going to do is we're going to ask hatch to destroy our bullet 0 object. Okay. And now we have to renumber all the elements. So there's a very simple JavaScript function for your arrays for that called shift. So you can just say bullets dot shift. It just bullet dot shift function in an array remove the first element and reindexes the remaining elements from 0 to the last value. You don't have to give anything inside the round brackets here. Okay, this should now destroy my any bullet that moves beyond a Z coordinate of -10. Okay, let's run the script and see how it works. Let's fire one bullet and see if it gets destroyed or not. Yep, it got destroyed. See, now I'm going to fire multiple bullets and you'll see they get destroyed. They are getting destroyed after. I'm going to show you visually that it's visible. I hope it's visible because I can see and it's really exciting for me. So the bullets are getting destroyed. So now my code is going to run efficiently. As in, at any point of time, it's not going to be like there are numerous number of bullets in my game. Okay, cool. Bullets destruction done. What's remaining are enemies. Okay, enemies. Enemies. We're going to add now. We'll take max 5 minutes. That's all. So how do we add enemies? Go to 3D models, Sketchfab. Now on Sketchfab, I've already added Invader models. So I just search for Invader. And I know where my models are. So 1, 2, 3, 4, 5. So I have 5 enemy objects. You can see all of them are added in my game. Okay. Now again, just like we did for our bullets, we are not going to be using each of these. We are going to be creating multiple copies of this, and we are going to spread them here. So when I showed you the example, you saw that there was a grid of enemies. So we are going to create that grid of enemies from this object list. So I'm just, first of all, the sizes are too big, so I'm just going to make them small. 0 0.5, 0 0.5, 0 0.5. Then this one goes 5, 0 0.5, 0 0.5, 0 0.5. Okay. Enemies added. I need to make them invisible as well. I don't need to see them, see the actual objects in the scene, I will be able to see the cloned ones. So yes, let's do this. I am just going to make each of them invisible. Done. So now there's nothing left. Okay. I'm just hoping that you guys are bored. Okay. Uh, no, fingers crossed. I mean, yeah, enemies. How do we add enemies? So just like we did for bullets, we are going to create a function that is going to create enemies, that is going to create clones. But clones, understand how we are going to be creating clones. We have 5 enemies. Each of them are going to be spread like this. So we have what do we have? We have enemy 1, enemy 2, enemy 3, enemy 4, and enemy 5. Okay, and we are going to make a grid of all of these enemies. Like one row is going to be filled only with enemy 1, first invader, right? And then the second row is going to be filled with the second invader, and so on, right? So see, first of all, what we can do is we can go slowly here. So we're going to create a variable that I'm just going to add all of the current 5 invaders in an array. So I'm going to call the array enemies equal to, and here I say invader 1, comma invader 2, comma invader 3, comma invader 4, comma invader 5. Good. So the reason I'm doing this in an array is because later on I can just, to reference any of these invaders, I can just reference it through my array. Okay. And now we're going to write the code to uh, go through each of these invader elements one by one in a loop and create, let's say, 11 clones of them. Okay. So how do I do that? I'll just use a for loop. For, so I'm going to go through each of these enemies elements one by one. So for I equal to 0, I less than enemies dot length and I plus plus. And what do I do? So now this for loop is going to go through each of the elements of my enemies array. Inside that, now we have to write, because I want to create 11 clones of one specific invader object. So I'll need another for loop inside this for loop. That will now create copies of my selected invader 11 times. So I just write another for loop. So this is called nested for loops. I use another variable j equal to 0, j less than equal to 10. So less than equal to 10 is going to 10, and then j plus plus. Cool. So this for loop is going to, the first for loop is going to go through each of the, select which invader do you want to clone, okay? The second for loop is going to clone the selected invader 11 times. Now, we'll call the function, we'll create a function that is going to create enemies. So function create enemies, and I'm going to call that function here. So if all throughout this loop runs, I'm just going to create my enemies. Okay. Now my enemies will need this I and j values to know how many clones are getting created and which invader is going to be getting cloned. So in my create enemies function, I'm going to pass on two local variables, u and v, and I and j are going to be equivalent to u and v here. Okay. So u is equal to I. That means it defines which enemy object is going to be cloned. and v defines how many, v is equal to j, right? So how many times my selected enemy object has been cloned already. That is what v or j is telling us. So now what we can do is we can just first of all add the clone object option, add clone object, and yeah. So you need to define which object you want to clone. This is where you use the variable u, because now I can say that from the enemies array, refer to the element with the value with the index u. U is equal to I, because so the local variables, when defining a function, you create a local variable, and then when you're calling a function, you give values to that local variable. So right now, whatever value I has, if I is 0, then u is 0. If I is 1, then u equal to 1. If I is 2, then u will be equal to 2. So whatever value I has will be passed on to the variable u. Okay. So so if I is 0, basically enemies at the index 0, that is invader 1, right? Like that. So we are telling which object to clone. Now we are telling uh, where to clone. Okay, where to clone. So where to clone. So let's see. If we have a grid of objects like this, so, and what we are going to do is we are going to have, so this is going to be our x coordinate, and this is going to be our z coordinate. So for a specific invader, the z coordinate is constant and the x coordinate is changing. See that? And for different invaders, the x coordinate here remains the same and the z coordinate changes. So for a specific u, what we can do is we can now just say what's going to be the x coordinate of my let's say I'm copying, let's say, invader 1. Then what's going to be the x coordinate of that? I'm going to clone it 11 times in the x coordinate. We can, let's say, it goes from -10 in the x coordinate to +10 in the x coordinate. So the very first object gets created at -10 in the x position, and then we create the next object at, let's say, -8, then -6. We keep on adding 2. We can keep on giving each of those enemies a space of 2 units. So I can just do that then by saying -10 plus 2 times. Now, how many clones have been created is referenced by the local variable v. Remember? So v. So if I'm creating the very first clone here, so u is 0, v is 0. If I'm creating the second clone here, u is 0, v is 1. So this one's position is -10 in the x. This one's position is -8. -10 plus 2 times 1. This one's position is going to be -6. That is -10 plus 2 times 2. -10 plus 4 is -6. Okay, so that's what this code is doing here. Okay, and just similar logic for our z coordinate. Only in the z coordinate, v is constant, u is changing. So we do that. We can again start with it's so this is something that I'm doing according to what I have thought of. You guys can change it, place your enemies wherever you want. There are lots of ways you can place your enemies. It's not like this is the only way to do it. I'm not saying that. Don't quote me on that. Okay, so 2 times u. Okay, and yeah, so we have positioned our enemies. What we have to do is we have to uh, yeah, don't spam. Please don't spam. I mean, chatting is fine, but don't spam. Clone object, you have to make the clone object visible as well. Okay, so clone object visible as well. How do we do that? Clone object dot set visible to true, right? This should work. That's all. That's all. This should work. This should technically create a grid of enemies. Run the script. hmm Yep, yep. Okay. Um, Turn the camera on again. I'm sorry, but okay. We did it. So you can see the thing is it's cloned. It's cloned. They are placed up and down. That's what I was trying to figure out what's wrong here because this was not looking correct. They are cloned, but they are not looking correct because what had happened was the each of these invader objects they are taking the y coordinate of the object from which they are cloned. And remember in the design mode, those enemies were spread all over. I'm just going to give all of these objects a y coordinate of 0. Cloned object dot set y of 0. Yes, this should work now. This should work. Yes. Okay. Awesome. So this worked. We have a grid of enemies, but they're too close. Um, I want them farther away. I can just make the U negative. That will make it move behind, farther away. Yep. Perfect. Grid of enemies created. Now, okay. Damn it. I have been using so much time. Wow, this has been going on for 1 hour. I'm really sorry. This is such an extended. So just two parts left. Move the enemies and kill the enemies. Let's go faster. Let's go faster. Obviously, let's go faster. This is I'm going too slow. So move the enemies. What do you do? Uh, so now these objects, the grid of enemies that we have created, just like we saved all the bullets that we were creating in a bullets array. Let's say these enemies are not saved anywhere. We can't, we don't know the names of these enemies, right? So if we are able to save all of these in another enemies array, then we can just loop through the entire element of that array and move the object. Okay, so see, just watch me. Variable, I'm just going to create enemies pool that is equal to an empty array. All right, and every time I create create a new enemy, I'm just going to push it into the enemies pool array. So enemies pool dot push, and inside this I write what clone object. Perfect. So this is now going to, so all of the grid of my enemies are going to be listed in my enemies pool. Okay. So now what do? We are going to run another for loop and move all of these. So move the enemies. How do we do that? We are just going to create another function called move enemies, and we are going to run a for loop for let E of enemies pool. And what are we going to do? We are going to change the X position. We want the enemies to move left and right. We're going to change the X position. How do we change that? So set X to E dot get X. I hope I am not making a mistake here. E dot get X plus some speed value. Create another variable as usual. I'm going to go to the top. Um, Sorry, I have a habit of just having the variables on the top. You can have them depending on the scope wherever. Uh, I'm rambling, so sorry. Enemies speed e s e speed. Yep, that will work for me. And give it a speed, any number, minus 0.07 for now. These are random numbers I'm choosing. Okay. Who seems angry? I'm not angry. Oh, sorry. Um, yeah. So move enemies E speed. So for every element E in my enemies pool, E dot set X to E dot get X plus enemy speed. And right now, so now again, as usual, we are going to call this move enemies function in my run game. so that it moves continuously again and again. Anything that we want to run smoothly, we are just like inside the run game, I have move ship, move bullets. I'm just going to write the name of the function now. See, I don't have to do anything. Just create the function, write the name inside the run game function, and it will just run smoothly. So simple. So, what was the name of the function? Move enemies. Move enemies. Yes. Sorry. Okay. Move enemies. It should work. Now let's run it. Sorry, I'm just okay. Let's come. Yes. See, you guys can see that the enemies moved away. Oops. Enemies moved away, and they keep on moving. So good. And enemies, we just need to make them move left, then right, then left, then right. Basically, we just need to see that if they have crossed a certain x position, then reverse the value of their x speed. Like right now, their x speed is minus 0.07. See, if I change their x speed to 0.07, they will move. So all we need to do is, yeah, all we need to do is define x limits, x position limits, and then our limits are going to just toggle the x speed between the x boundary conditions. What I mean by that is, anytime I move this, anytime I move my enemies, let's just check for our very first enemy object. Yeah, very first enemy object is going to help us a lot. So very first enemy object we create what at at minus 10 comma minus 10, because you see we had said minus 10 plus 2 times v and minus 10 minus 2 times v, and u and v for the very first enemy was 0 and 0. So the x and z position of that enemy is at minus 10 and minus 10. So we are just, its x position is at minus 10, and it's moving where? It's moving, let's say right now it's moving to the left side. So we can just say, after it moves, if uh, enemy's pool index 0, that's the first element, its get x value, its x coordinate has become less than minus 20, then what do? We change the e speed to 0.07, because it was going to the left, we wanted to go to the right side. And similarly, we write else if, I can do this in one line of code, but it's better to show you this way. Enemies pool 0 dot get x greater than 0. So its position was at minus 10. We are checking its boundary from minus 20 to 0 in the x coordinate. And if it exceeds beyond 0, greater than 0, then e speed becomes negative again. This should work. Our enemies should now oscillate. What happened? Yeah, okay. See, it's oscillating. Good. Should say something? Wow, you guys are okay. Cool. Almost done. Almost done. Just we have to kill the enemies now. Simple. That's easy. So our enemies are oscillating. We can see if I move, everything is done. All I have to do now is add the logic to kill the enemies. That's easy. That's the easiest part. Just do this. Whenever detect collision for each of those bullets with each of those enemies, and whenever they hit, uh, turn off their visibility, both of their visibility. It's a short trick. There's a longer method. There's a more trickier method that can remove them from your code itself and will make your code much lighter. But it involves a lot of stuff that we haven't. That will take time. We're not. So we're going to go through an easier method. I'm going to create a function, kill enemies, and I'm going to say, first of all, I need to check if bullets exist or not. So if bullets dot length is greater than 0, then for each bullet, let b of bullets, for each bullet, detect collision with the entire enemy's pool. So what I can do is I'll just add one of these detect collision with functions from here and change the IDs. Yeah, detect collision with, so b dot detect collision with the entire enemy's pool. And out of those out of the elements of the enemy's pool, whichever object my bullet is colliding with, store that in the collided object variable name, a temporary name. And then what do we do with both of these? We are going to make both of them invisible. So b dot set visible to false and collided object dot set visible to false. Good. One more thing. We're almost done. Just one more line of code. See, even if my bullet has turned its visibility off, it can still collide with other enemies. Once a bullet has collided with an enemy, we don't want its collision to be detected anymore with any other enemies. Okay, so what I can do is, because I'm already turning its visibility off, so here I can just do a check if B is visible. Only for the bullets that are visible, detect collision, otherwise don't detect collision for the invisible bullets. And then move the entire code of this detect collision here. We're done. I mean, this should run our entire game. I'm going to tab. Hopefully it runs. And wow, I have taken a lot of time off you guys. Let's hope this kills our enemies. Oh, it didn't kill. Oops. What happened? Something happened. Let's run it here so see what error happened. I might have made stupid mistake, obviously. I'm just going to fire one bullet. It's going to hit something. What did I do? Collision with enemy's pool, collided object, set visible. Is visible. My bad. Sorry. The is visible thing needs round brackets. Now it should run. One bullet should. Huh. Hmm. Actually, bullets. Oh, my bullets are still disappearing at -10 value. Oops. Sorry. I know. So you see here, where we were destroying our bullets, our enemies are beyond Z equal to, and my bullets are getting destroyed by the time it reaches -10. I need to increase this. I need to make it -60, and I just make it if bullet is visible equal to. Actually, that doesn't. Yeah, now it should work. Did I not call the kill enemies function? Okay. Too many mistakes. Sorry. Uh, Kill enemies function. Yes. You have to call the function obviously. So it needs to be continuously detecting if the collision is happening or not. Just like so. See, for the motion stuff, you can see that the motion is continuously happening. So you can see the use case animation frame there. But for kill enemies, you cannot see the use case immediately because only when the collision happens, the objects get destroyed. But while the collision is not happening, my computer is still checking if the collision should be happening or not. Okay, So we need it inside our run game function, where it checks again and again and again and again. One bullet. Oh, please, this. Yes, yes, yes. Okay, it works. Let's. Yes, it works. Right. Yeah. Uh, yeah, my system is heating up. Uh, cool. This works. You guys, it's already available in the gallery. I will share the link on the Discord channel. This was too long of a video. This was, uh, uh, yeah. I mean, okay. I should can suggest. I should be suggesting that there's one more thing we can do to make this run more efficiently. If you want to suggest, Anshul, I'm looking at the messages. I can implement that here. But otherwise, what we can do is see. You guys also can figure out there are multiple code this to run it efficiently. If you guys are familiar with object-oriented programming, like we can use class objects to make this run at a very faster pace, at a very efficient pace. But in later episodes, I've taken up a lot of your time, and I just hope you guys learned something. Try this out. The the Hatch Kids project with the code and blocks window, or link of that project and link of this project are going to be shared on your Discord channel. There is a K12 TV Discord channel. I hope all of you are in that. You guys can access the link from there and play with this project, remix the project, modify the properties however you want. And I mean, one thing you guys can do is, I don't know for the younger kids, but older kids, if any older kids are watching, try out enemies in a circular area. You will need trigonometric functions, and you will need to find out the directions in which the bullet is going to be fired rather than just firing it in a z direction. So it will involve a lot of mathematical calculation as well. Try that out. Younger kids, try this out in the blocks code. I'll share the blocks code with you guys, so you can experiment with that. And in the next video, in the next session, Niharika ma'am is going to take your class again. She's going to show you something. But after that, a week after that, okay, I'm guessing everybody got bored with this one. There's some more maths tricks that we can do on Hatch. That's what we are going to cover in 2 weeks after this. Okay. So I really hope to see you guys there. All right. I'm going to end the stream now.